Hello class, welcome to Unit 5.2A, Solving Compound Inequalities. Today we're going to look at three different types of compound inequalities. And the first one we want to look at is the ors. So again, think about the words ors. That means it's one or the other. It can be both. So typically with or, what we need to do is just solve them, graph them, and then of course just take a look to see if we can simplify anything. So, as we work through them today, we still need to follow all of the same inverse operations. So when we see subtract 5, we add 5. We see multiply, that means we need to divide. And the first part of this graph is just going to tell us x is less than 5. Okay, same thing here, subtract 1. Divide by -2. Now again, we've been talking about how if you divide by -2, the first thing we need to do is flip that inequality sign. So this is going to make x greater than 9. All right, well, we've got to add a little 9 to that. And go this way. Now this is an or statement. So when you see those two lines going opposite direction, it could be less than 5 or greater than 9. There is no reason to simplify, and those two parts are going to be our answer. Okay, looking at example 2, same deal. All right, start by solving. Add 3. And that's less than or equal to a -2. Multiply both sides by 2. Now we are not multiplying by a negative, so do not flip your sign. And the first part's going to say x is less than or equal to -4, which is a closed dot going that way. And if this one here is having us divide by -2/3, so going to probably be a little bit easier when we multiply by the reciprocal. So multiplying by a -3/2, which is going to cause that to cancel. And because we are multiplying by a negative, we need to remember to flip our sign. 4 times 3 and a -4, that's going to be 12 divided by 2. So that is going to end up simplifying to greater than 6. So if we look at x is greater than 6. Now again, this is an or statement. So we want to make sure our final answer puts both of those answers together. X is less than or equal to -4, or x is greater than a 6. Okay, that's it for examples. Take a minute here to pause, complete these practice problems. Don't forget things like the distributing and dividing by -1s when we have to. All right, good luck. Okay, take a minute to check your work. Double check your calculations, your adding, subtracting, dividing, flipping signs where we need to. And example 5, take a look. Don't forget, again, multiplying by 4 to start off. We've been looking at a few of those. Flipping your sign when you divide by -5. Okay, let's take a look at some more. Okay, the second type of problem we're going to look at today is our and statements. So remember, this is something that has to be, something that has to be happening at the same time. It needs to be this and that. So now we're going to be looking for solving our inequalities separately, graphing them. But now we need to figure out where they're both true. So start with solving. We subtract 4 from both sides. 2x is less than 4. Divide by 2. So the first part of this is going to be x is less than 2. So that's going to be going this direction. We go over here and solve the second part of the equation. We've got +5. So now we've got 3x is greater than or equal to -6. And then when we divide both sides by 3, x is going to be greater than or equal to negative 2. Now, it's important to remember that these are and statements. So when we look at x is greater than or equal to negative 2, and it goes this direction, remember, these were the ones where when we test each spot with our and statements, we need where it's both true. Well, over here is not both true. Over here is not both true. The only part where they are both happening is right here in the middle. So that goes back to just kind of checking those answers. Now, the last thing you want to do is with that, now this answer over here could potentially be an answer, but 95% of the time you're going to look at something that starts with negative 2. That's less than or equal to with our closed dot. Remember that x is going to be sandwiched in between a negative 2 and a 2. So that's telling us that x has to be greater than or equal to negative 2, but also less than 2. So more times than not, this is going to be your final answer. Okay, let's look at example 2. Again, we just need to start by solving. X divided by 3 is less than or equal to a negative 1. When you have to divide by 3, we're multiplying by 3. So now x is less than or equal to negative 3. Now this is going to be and whatever is happening over here. All right, so again, we need to multiply by the reciprocal. Instead of trying to say divide by negative 1/3, let's multiply by the reciprocal, which is going to cancel over here. Let this be x is less than negative 6. All right, so what we're really looking for is something that is less than negative 3, and x is less than negative 6, which actually, if you're kind of working too fast, don't forget we need to flip that inequality. Multiplying by a negative is going to cause us to flip the inequality. So what do we have here when we start graphing? We have x is less than negative 3, so that's going to go this direction. We're going to have x is greater than negative 6 and go this direction. And again, when we start looking at where are they both, over here is only greater than the negative 6, and over here is only greater than negative 3. But where is it the and? It's going to be in that middle section. So what we want to do is we're going from negative 6, close dot our x, and that's less than or equal to that negative 3. So we get that x sandwiched between our two endpoints. Okay, and that's it for our examples here. Take a minute and pause so you can practice these problems. Again, just solving, graphing, interpreting, and working through before you check your answers. Okay, here's 3 and 4. Pause and check your work. And our third example here. And notice when we're doing a lot of these, typically the and statements end up sandwiched between two numbers. We did talk the other day about how some of our and statements or statements end up, kind of going in the same direction. But typically this is what you'll see. Okay, so this is our third example, which is going to take a look at and statements. But this is already going to start sandwich, right? All of those and statements we were writing, kind of like you see here, 3 is less, or x is greater than 3, but less than 10. So what we could do is break it apart into two smaller ones. But you also have the option to just solve this all at once. But instead of an equation where there's only two sides, what we essentially have is 3 parts to this inequality. So when you go to solve it, we still need to look for the x and say how we're going to solve for it. And the first step is going to be subtract by 4. But since there are 3 parts to this inequality, essentially you need to kind of draw those invisible lines down through where we need to subtract 4 from every part. And then that's what that's going to leave us with. And kind of working through is just kind of continue to simplify. And then when we divide by 2, again, we're dividing everything by 2. So when we do that, through there. Now the thing here is, the nice thing about this is if you solve through, this should be our answer. But always kind of just break it down to make sure. So x is greater than -6, so that's going to start here with a closed dot. And that's going to tell us greater than going this direction. That's good. And then when we look at the other part of it, that's saying at 3, and x has to be less. So good. That is going to sandwich ourselves right between there, and that's our answer. Okay, looking at example 2. All right, a little bit easier. And the only thing we have to do here is divide by -3. Now again, we are dividing by -3, so this is going to tell us we need to flip, and in this case, both of our signs. And then we continue solving. So -12 divided by -3. 6 divided by -3. Now this is a little backwards of what we're used to. So we might want to reconsider just kind of rewriting this so that our x and both of our signs kind of flip. And just kind of make sure this makes sense. So this is trying to tell us we can go from a 2, okay, greater than, going this direction, but also has to be less than 4. So not a whole lot of range of numbers we can go for, but that would be what we're looking for. All right, let's take some time to practice. Pause here and practice these next couple problems. Okay, and let's stop and pause and check your work. And the last one. So again, might help to kind of rewrite this one before you try to graph. Okay, so that is a look at the 3 different and or compound inequalities. And right now, like I said, we're not kind of working on much of those special cases of like the all real numbers, no solutions, but they will slowly kind of work their way into our work. But what you saw today is going to be more typical of, typically with your and statements, you're going to see something sandwiched, and if you're looking with your or statements, that's when you see them going opposite. So just kind of general rule of thumb. That's our, I guess, normal cases, you could call them. But there are those kind of special cases that could happen from time to time. So make sure you kind of finish your practice in Canvas, and good luck. Have a great day.